Yeah, so I'm Bart. I work for this place. CSIRO, as you all heard about yesterday at the podcast, is Australia's scientific arm of the government. So I've been there for the last 17 years, and I've been primarily Mac admin there since 2011, and before that, the Mac guy by de facto. So yeah, no, working there is pretty great. Obviously, I've been there for a long time. We do all sorts of science stuff. Basically, if it's scientific, we do it. Yeah, it's really, really good. So this talk, I'm trying not to make it a tutorial. It's not a how-to. It's not a... hopefully, the idea of this is to bring you up to an understanding of sort of LaunchD. It's been around for a while, but yeah, the reason for bringing this up was that I was on Slack. This was about a year ago, and someone had asked the question. They wanted to say, "I just need this script to run when a user logs in," and one of the first responses that came back was use outset. Now we'll get to outset later on, but for this particular task, it was, and this is just my opinion, but outset was it does a lot of things, it's great, and it's a good tool if you have a need for it. For this particular task, it was overkill, and it does another thing, which is it stops you from knowing how the system works and why you're actually choosing a particular tool. So yeah, so my philosophy has always been as an admin to know not just what you're running as an admin tool, but why you're running it, why you're choosing that particular tool, and why you might choose a particular tool over something that's built into the OS by default. And for something as simple as running a task when a user logs in, LaunchD absolutely kills it at that. That's what it's designed for, that's what it does. And choosing something else because you don't understand how LaunchD works just is masking your understanding of how the OS works. So, yeah, it's okay not to know everything. I don't know everything. I don't quite know everything about LaunchD even. It's a big, massive, pile of stuff that runs the system. It's a bit of a beast, actually, and there's a lot of confusing things. If you go and have a look in the documentation for LaunchD, it's very easy to get confused, and so hopefully this talk will just sort of highlight the bits and pieces that as a sysadmin you need to care about for both running your own tasks and troubleshooting tasks that are installed on the system by other software or by default. So LaunchD, where did it come from? How did it start and why does it even exist? So LaunchD, it was released by Apple with macOS 10.4. So it's been around for quite a while. It was written by a guy, he started at Apple when he was 17. When he wrote LaunchD, I think he was like 23 or 24, something like that. So it is responsible for starting all the system services at boot. So it will bring the machine up, it'll run all the services. It also loads and maintains system services while the OS is running. Runs all the scheduled tasks, runs watches for network activity and launches things as needed. And it basically replaces a whole bunch of Unix subsystem components that exist in Unix prior to this coming out. So essentially, it's God. It owns the system. It makes sure that everything is running. For the Unix nerds, what LaunchD actually replaces is init, which is the first process. It's the parent process of all processes. Replaces RC, which is the run command tool for running things. Replaces system starter, which existed in macOS. I think it came out with 10.2. and it was the precursor to Launch D, if anyone sort of goes back that far and has ever dealt with System Starter, which was actually present in macOS up until 10.9. It replaces inetd and cron and watchdog D for just keeping track of tasks. So yeah, holy crap, that's a lot of stuff. And it's no small wonder that, you know, if you're sort of new to macOS management and you go and have a look at these things, it's very easy to get confused. So you can check out the LaunchD man page. So you can open up terminal, man LaunchD, and it will tell you everything about it. And it'll tell you at the bottom of the page, these are the areas in which your LaunchD plist will be located. So essentially from the outset, we can ignore these two. So system library launch agents and system library launch daemons. Don't go there, dragons live there, they'll bite you, there's lots of fire and pain. So we only want to have a look pretty much at these ones. Library launch agents in the users folder, launch agents in the library launch agents folder, and library launch daemons. And we'll have a chat about what these do. So, we want to touch God. We want to interact with this thing and make the system do our bidding, I guess. So let's have a look at what the kind of things we might want to be able to do in a system. So, you know, we want to, you know, launch a service or run a job when the system boots. So that would be, you know, we would run a launch daemon for that. It runs as root, and we want it to do something that is user independent. You know, we might want to launch a service when a user logs in. We want to, you know, write a log, or we might want to run a program for the user to do something. Or we might just want to have a service run at a schedule, so every, you know, 30 minutes or every 2 hours or once a week or something like that. So these are just, you know, maintenance tasks that we, you know, just for general maintenance of the system or what have you. A blank slide, I don't know why I've got a blank slide. So, agents and daemons. Actually, we're on Darwin, so this daemon's a bit better. So if you don't know that guy, that's Hexley. He's an unofficial mascot of Darwin, which is the Unix OS that underlies Mac OS. Not affiliated with Apple at all, but everyone seems to like him. He's pretty cute. Anyway, so what's the difference between agents and daemons? So this is a launch daemon. So daemons run as a system. They don't have any GUI interaction at all with the system or with the user, and they should be fully self-contained. But just as an example, you can see the structure of just a very simple agent. We have a label, identification label. We have the program we want to run, and I've just included a run at load key here. That's actually optional, but if you don't have that, it's not going to run. It'll load the job, but it won't run it. So we put that in there, and that ensures that the program will run every time the job's loaded by LaunchD. Launch agents. They look exactly the same because the definitions are exactly the same. So the main difference is that a launch agent runs in a user context. It operates on user data, and you can actually have it run GUI applications if user GUI is present. So agents and daemons, they're configured the same. So if we know one, we know the other. We should be able to identify any issues, you know, between the both, and as long as we keep in mind that you know, users can have GUIs, but root doesn't have a GUI and stuff like that, then we should okay. So this is a good thing. So we can for the purposes of the rest of it, I'm just going to talk about launch daemons, but it will be essentially the same. So I might say daemons, but it could be daemons or agents. So, yes. Another slide with a question mark. Why did I put that there? Because I didn't put any notes because I was writing this morning. So we can look at launch. LaunchD is essentially a list of commands that if the conditions are met, then the system says, go, run this command. Everything in the specification for the agent needs to match. If none of them match, nothing is done. The agent is loaded in the system, so LaunchD will actually load an agent, and by that, it'll know about it. This is where the label becomes important. And it will essentially sit there and it'll watch the state of the system, and as soon as those conditions are met and you get the go signal, it takes off. Off it goes. It's kind of like a party in a box, really. The metaphor I was going to go with this was the way LaunchD works is it's the fuse. If the conditions are met, you light the fuse, and then you run away. And then the party in the box goes off. And there's an interesting little, I'll get to it a little bit later on, but there's a little quirk about the way that it runs, which makes this metaphor a little bit relevant, in that once the fuse is lit and the job is run, essentially it's up to the party in the box to end itself. It's the only time LaunchD will then come back and then kill it is when the system's shutting down, and it becomes important. Since I had a party in the box, I thought I would. This is probably the only time that this actual keynote animation is relevant. I think it's just I don't know when it's. Why would you use that? Anyway, whatever. I saw it there, it was nice, and I was talking about fireworks. So as an admin, there's a whole bunch of keys in LaunchD because the definition is used for launching a whole bunch of system servers. There's a whole bunch of info in there, but there's some key common keys, configuration keys that we could know about. You can go look at the man page for launchd.plist. And that will give you a nice whole list of everything that is available, and I mean everything. But the key ones, the key keys, this one. So the first thing you want is a label. So every LaunchD plist needs to have a label, and this has to be unique. So this is the way that LaunchD is going to identify your job, and it's going to identify that this process is whatever it's acting on. So if you have multiple plists and they all have the same label, you're going to have issues. You need something to run. So there's two keys that can do that, program and program arguments. Program is just literally the path to the program you want to run, and that's all you have to put in. And LaunchD will happily run whatever that is. If you want to supply arguments to it, you can have the program key and the program arguments key, or you can just have the program arguments key. Now, it's not just program arguments, so the first string in this array is the path to the file that you are running. If you have this key here, LaunchD will use this, and it will ignore the first line there. So that will be passed through as essentially index 0, so $0 in your application. But for the effect, if you're running program and not using it here, it will effectively ignore it. So, but you need to have the first line needs to be the path to the application you're running, even if you're running program. So it's a little bit confusing there. Personally, if I'm running this, I just leave out program entirely and I just use program arguments. It just makes it a whole lot simpler for debugging. So you just run the application, and then each option is just its own string. And so you'll have, whenever there's a space, like if you write the terminal, your command out on the terminal, anytime you have a space, you drop to a new string. Run it load. So run it load tells LaunchD that when you load this plist into memory, run the job. So the first thing you do, launch it. It has two Boolean settings. One is true, one is false. I don't know why you would use false. You would just leave the key off entirely. But the option is there to put it in if you want to. If you want to be explicit about it, I guess. So run it load. True is generally a good thing if the thing you want to do is you just want to make sure that this runs whenever the computer starts and you don't care about when, as long as it does. Another good one is start interval. So this one will load the job and it will tell it every 7,200 seconds, or every however many seconds you put in there, run the program. So this is good for if you have like maintenance programs or things that sort of update some sort of resource or whatever. You can tell it just to keep running every so often, and it will happily do that. If you don't want to be at the whims of when that runs, you can actually use a start calendar interval instead. And this takes a variety of keys for determining the day, week, month, year, hour and minute of when your job wants to run. So you can specify exactly the time that this runs. You can have start calendar interval and you can have start interval and start calendar interval specified, and if you do have both there, LaunchD treats them completely separately, and it will happily run both. So it'll do the start interval, and it will do the calendar interval. So you could actually have multiples running. So just sort of be aware of that. If that's what you want it to do, then great. LaunchD will happily comply. So for a calendar interval, we can go month, day, weekday, hour, and minute. Months are obviously, 1 to 12, first being January. Day being 1 to 31. I think that's fairly self-relevant. Weekday, 0 to 7. 0 is Sunday. You'll notice that if you count from 0 to 7, there's actually 8 numbers there. It's because 7 is also Sunday. So that way you can have, essentially if you just think Monday, Tuesday, Wednesday, Thursday, Friday, and the weekends. So hours 0 to 23 is 24-hour time. Minutes 0 to 59. So a basic one, you want a job to run at 8:30 in the morning. You put that in there, and LaunchD will then run your job quite happily. 8:30 every day, it will run. If you want it to run at a separate time during the day as well, you put in another dictionary with the time that you want it to run there as well. So at this, we're doing 8:30 in the morning and 5 in the afternoon. So we'll have a morning task and an afternoon task. If your laptop is closed or the machine is asleep, when the 8:30 timer hits, the first time it wakes up, it will actually run the job. So what it does is if it misses a time slot, then it will just know that I should have run at this particular point in time, and it will then run the job. So if you set something to run at 8:30, for example, and someone comes in and they don't turn their machine on until 9 o'clock, then the Mac will go, oh, I needed to run this, I'll run it now. So it's not an explicit 8:30 and only 8:30, it will actually back those up. And it only backs up one, so if it misses like half a dozen of these things, it'll just do the last one it missed. So this is a nice one. Let's see if I got the time right. Almost. So this would be the 6th month, 28th day, 10th hour, 20th minute. I could probably make that the 18th minute. I timed that all right, actually. And weekday 5. So looking at this, it kind of looks like it would run on June 28th at 10:20, as long as it's a Friday. So that's a combination that only occurs once every 11 years. However, if both day and weekday are specified, then if either matches, then LaunchD will trigger the job. So it will match if it's a Friday, or if it also happens to be the 28th of June. So just be aware of that one as well, just in case you didn't want the job to run every 11 years or whatever. It can get very verbose. If you want to run something only on a weekday, so only on work days, and you want this thing to run, you don't want it to run on weekends, unfortunately you have to specify every day as a separate dictionary. This can get messy if you want to run it multiple times a day, but only on weekdays. So you'll end up with a very long list of things. Cron is a lot better with this. LaunchD is one of the pitfalls, so you can actually get some slightly messy ones. Generally what I do is I put logic in my job to actually say, is it a weekday? If it isn't, then just bail. So, but whichever. So they're the basic keys. should get you started. There's a few slightly more advanced keys that we can go through that make things a little bit more interesting. So one is watch paths. So this one will look at this particular job, and if it's a file, if the file is created, if it's modified, or if it's removed, then LaunchD will start the job. So you can say, watch this file. If it changes, run. If it's actually a path to a directory and the directory changes, or you add any files to the directory or modify any files in the directory, it will also launch the job. So you can have it watch a file or a folder as well. Keep alive. So keep alive is an interesting one. You can set it, so if you have a program that runs, does a thing, and then exits, and you have keep alive true, then as soon as it exits, it will run it again, and it'll keep doing that forever. It does exactly what it says, it keeps it alive. That actually comes in handy if you have it's more useful if you have like a GUI app, like a help desk thing in the menu bar or whatever, and you want that to run. You can have keep alive set to true, so that if the user goes and closes it, LaunchD will actually relaunch it again. So you can keep those things running in the case of you want it to always be there and you don't want the user closing stuff. Keep alive has a few other options. So you can have, the first one is just basic true, just keep it alive. This one is path state. So you can say, if this path to the file exists, then as long as that file exists, keep the job running. If you have a look in the documentation for this, it actually says if the value of the key is true, then the job will be kept alive as long as the path exists. Now, if you read that, it makes you think, well, I can create a file and I'll have a job run, and then when I want the job to stop, I'll delete the file. That doesn't actually happen. LaunchD, this is where the party in the box thing comes in. LaunchD lights the fuse and then you run away, and then it's up to the party in the box to do what it has to do. So if you have a program that runs in a program loop and exits by some other means, then if you have this keep alive state, it won't actually shut down the job. It will keep running and it'll be up to the program to exit itself. This is used for a couple of neat little things which I'll get to in a little bit. Conversely, you can have it set to run if a file goes away. So this one, I've got the path to file is true, and this one's path to file is false. So you can have either or. Put it in the box, light the fuse, run away. These two are very interesting. So you can have a standard out path and standard error path. If you have you've written a script and you want to check the output every so often, so normally LaunchD won't save any output, so standard input, standard output won't be saved. You can put these in place, and then you can give it a string in a different color font, because I wrote this slide earlier, where you can pipe the error and the standard out to a file, and then you can check that out later. This is very useful for debugging, because otherwise LaunchD will not give you any info whatsoever. Throttle interval. Throttle interval is a good one. It's if you have the keep alive flag set and you have a job and it exits, keep alive interval, the throttle interval, you can set it to an incher and it will wait that number of seconds before it relaunches the job. If I was using keep alive true, I would always use this in case for some reason the job kept crashing all the time. If you have it just constantly restarting, it actually takes up a lot of resources, so having it wait at least 30 seconds or a minute or so before relaunching gives you a chance to actually debug things. We'll have a look at I'm going to say some common applications, but I only picked one, and that's Munki, because I know Munki. So if you have a look in library launch daemons, Munki has launch daemons and launch agents. We're just going to have a look at some of these. In fact, we're going to look at these two, which is the update check and the manual check. If we have a look at the update check, you can see we have the label there, so that's unique. It tells LaunchD we're looking for update check. We have the program arguments, and this is the arguments that Munki runs. So if you were to type that out on the command line, it would be all of that as one big long line. And we have a start calendar interval that says run every 10 minutes. Now, because the way Munki works, we've got these random delays in here, so the job will actually start, and then it's up to LaunchD. LaunchD will run, it's up to Munki to actually handle its own timings and all that sort of stuff. If the job's already running, LaunchD will try and check to see if it's running every 10 minutes, but if it's already running, it'll just ignore it. So this sits here and does its normal timeouts and whatnot, and you end up with your update checks on a schedule based on these things here. But you could, if you wanted to, put a calendar interval and change that and make it run less often. And that's kind of gone off the screen there, hasn't it? The curtain's in the way. We'll ignore that. The manual check. The manual check's an interesting one. So in Munki, as you know, the user runs Managed Software Center, and Munki does its thing, and Munki does everything as root. So this is actually how you can have the user interact with the program and then get the system to run something as a root context without actually giving that user direct access to that. So again, we have a keep alive at this path state. So when you click that update check in Munki, it will write this file, and as soon as that file exists, it will go through and it'll run. It'll go through and run that command. So this command is running as root, and it's being initiated by the user because it's touched that file. This highlights another thing. That file, it doesn't matter what permissions are on that file. LaunchD will always, as long as that file exists, doesn't matter who created it, doesn't matter if it's got any content or anything. As long as it exists, it will run. So that's a nice little way to get. How am I going for time? 3 minutes. About 3 minutes? All right. So interacting with it. So launch control. Check out the man page for launch control. It has a lot of stuff in it. Too much stuff. To load agents manually, you would just do launch control load, library, pass to the launch agent, that's fine. If you're running a launch daemon, same thing. Just be aware of the context. So if you type in a launchctl load or unload and you are logged in as a user, then it will run as that user. So just be aware of the context when running this. So there's unload as well. These commands are actually, if you have a look at the documentation, Apple says that these commands are actually legacy. Not deprecated, but they're legacy. There's actually version 2 of the commands, and they look like that. So isn't that much more simple? So this is a LaunchDL 2.0 syntax. This came in with 10.10, I believe, and this is just a sample to give you an idea of those previous 2 commands. This is how we would run it with the 2.0 syntax. So it'd be a launch control bootstrap, GUI users ID if you're running a GUI app, UID user ID if you're running it as just as a terminal app or a system context. And then you've got boot out as well. There's also a whole bunch of other commands like kickstart and then boot out and all sorts of stuff. It's very, very comprehensive. But check out the launch control man page and have a read of that and be utterly confused like everyone else on the internet. And that's why everyone uses load and unload. So we've had a look at all the command lines and stuff. What other alternatives are there? So login hooks and logout hooks, Apple say don't use them. They're a bit of a problem. They always run as root regardless, even if you have a login hook as a user. So Apple considers it a bit of a security thing. So they're still there, but sort of don't do it. Don't do it. Outset. Outset is a set of scripts which help simplify the running of tasks. So if you have a task that you just want to run once the first time someone logs in, or you want to have it run every time someone logs in, and these are common things you want to do and you've got a lot of them, then Outset lets you just it creates a set of folders, and all you do is you drop your script in the folder and Outset will run it whenever it says it wants to run it. The only thing I'd say with that is just make sure you've got the permissions set correctly on those folders. If you give write access to those folders, to a user who's not a privileged user, then they can throw stuff in there and they'll run as root. So just be aware of that. So Launchd.info is a great website. It's a great resource for checking out all these details about Launchd in plain language, in a way that is it's simply, it's not quite simply, but it's a bit more readable than Apple's documentation in the man pages. The guys that give this, everyone's got a photo. They make an app called Launch Control. And Launch Control, rather than interacting with everything on the terminal like we've just gone through, you can get a GUI and you can make your p-lists and you can check how they're going. You can see which ones have got errors. And it's all drag and drop. And the example I gave before with the running a task, once every day or everything like that, in Launch Control, it's much easier. You just say run it Monday, Tuesday, Wednesday, Thursday, Friday, and it creates everything for you. It's great. It's brilliant. That's the link for Outset. Just Google Outset. I've gone a little bit over time. And there's also Apple documentation as well, which is less readable than you would want.